All right, everyone, so here's the solutions to the integral quiz review for tomorrow. So number one, even though we've done most of these in class already. So number one, when you're integrating just a regular polynomial, so we have that the integral of x cubed is going to be x to the 4 over 4. Remember, you're just adding 1 to the exponent and dividing by it. Then the integral of 6x is going to be 6x squared over 2. And then the integral of 1 is just going to be 1x or x. Don't forget your plus c. And then because it's multiple choice, we're going to have to clean this up a little bit. So this is going to be x to the 4 over 4 plus 6 divided by 2, which is 3x squared, and then plus x plus c. Okay, so there's one question on there that's as easy as that. Please don't miss it. All right, number 2. So doing a little bit of changing here. I can't integrate this yet, but I can use some algebra and change a cube root of x to a x to the 1/3. Remember, how does that work again? This is x to the first power, so we're going to do in over out. So it's 1 over 3, okay? And what's that going to be when we add 1 to that? It's going to be x to the, remember, adding 1 is the same as adding 3 over 3. So 1 over 3 plus 3 over 3 is 4 over 3. And then we need to divide by 4 over 3, but dividing by a fraction is the same as multiplying by the reciprocal. So you're going to get 3/4 x to the 4/3 plus c. Okay, number 3, very similar. We need to add 1. So adding 1 is the same as adding 4 over 4. So negative 3 over 4 plus 4 over 4 is 1 over 4. Then when we divide by 1 over 4, that is the same as multiplying by the reciprocal, which is 4. And then don't forget your plus c. Okay, number 4. Okay, we've got some trig functions here. We did this one in class today, remember? So you guys, for this, remember that integral of e to the x is e to the x, right? So the integral of 3e to the u is just going to be 3e to the u, no change there. Then for this one, the integral of secant squared, we want to ask ourselves, what do we take the derivative of to get secant squared? Well, that would be tangent. So this would be tangent of u plus c. Okay, number 5. So this one, we don't know how to do the way that it's written, so we're going to have to go ahead and FOIL it out. So doing a little bit of algebra here, you're going to get 2 plus 1t squared, or t squared, minus 2t, and then minus t cubed. Now, after this, we can go ahead and integrate, right? The integral of any constant is just that constant times x, or t in this case. The integral of t squared is going to be t cubed over 3. The integral of 2t is going to be 2t squared over 2. And then the integral of t cubed is going to be t to the 4 over 4 plus c. And again, we're going to clean up a little bit. So this is 2t plus t cubed over 3. The 2's cancel, so minus t squared minus t to the 4 over 4 plus c. Okay, number 6. All right, so on this one, we need to remember that the integral of 1 over x is ln of absolute value of x. Okay, so on this one, whenever you're dividing something by just a regular old x, if there's just one x in the denominator, do not bring it to the top. You're going to get undefined, okay? So be careful. So I'm just going to instead rewrite this as 5 times 1 over x. So I can see this integral of 1 over x, okay? And then minus, there's not much I can do to the 3x squared. Now, the x to the 4th I can bring up. It's just if it's an x, I can't bring it up. So go ahead and bring that up. So it's going to be x to the negative 4th. Now let's integrate. So this, the 5 is just a constant. Bring it down. The integral of 1 over x, as we said here, was the ln of absolute value of x, minus the integral of 3x squared is 3x cubed over 3, and then minus the integral of x to the negative 4. So let's add 1. That's going to give us x to the negative 3 all over negative 3 plus c. So let's do a little bit of cleanup. So this is 5 ln of absolute value of x. These guys cancel out, so I get minus x cubed. A negative and a negative here are going to make a positive x to the negative 3 over 3, and then plus c. Okay. All right, number 7, we got a graph. So if you're given a graph of something and you're asked to find the integral, you want to think area under the curve. And again, we did this one in class today, right? So I'm just going from -3 to 3. So let's check this out. So I'm starting at -3 and I'm ending at 3. So let's make our boundaries here. So notice, remember when I make my boundary, draw a line straight down, but then you want to also bound it using the x-axis. So really what I'm finding the area of here is just this little region here. Okay. And then if I'm going to 3 on the right-hand side, I'm going to have this bounded by the x-axis. So this time I'm finding the area of this region here. Okay. All right, so let's do it. I can take this one and split it up here. So I know the area of this rectangle here. This rectangle is 3. I'll circle it here. This is just a triangle. Remember, a triangle is 1/2 the base times the height. The base is 1, and the height, if I go down here, the height is 3. So this is going to be 3/2, or 1.5. And then I can do the same thing with this, split this up. So this little square here is not a rectangle. 2 times 2, the area is going to be 4. And then this little triangle here, I'm going to have 1/2. The base is 1, and the height is 2. So the 2's cancel out. So this is just going to be a 1. All right. Now remember, if you're above the x-axis, it's positive area. If you're below the x-axis, it's a negative area. So the ones that are above the x-axis are the 1 and the 4. So I'm going to keep those positive. But then I'm going to subtract the other 2 because they're below. So -3 minus 1.5. So this is going to be 5 minus 4.5, which is just 0.5. Okay. All right, this one right here. So I'm given all of these little gifts here, right? And then all of a sudden, here's the question. So let's write down the question and see if we could separate it out a little bit. So this is the integral from 1 to 5 of f of x minus g of x. So you guys, some integral rules. Remember, we can split an integral over addition and subtraction. What does that mean? That means I can give each function its own integral. So this is going to be the integral from 1 to 5 of f of x minus the integral from 1 to 5 of g of x. Okay, let's look at the first one. I need to find the integral from 1 to 5 of f of x. So because it's f of x, I'm going to be looking at this, and I'm going to be looking at this. Those both have an f of x. This guy has a g of x, so I need to save that one somewhere, something else. Okay, so what is the integral from 1 to 5 of f of x? Well, this one gives me from 1 to 2. This one gives me from 2 to 5. So let's draw this out. So I know from 1 to 2, the area under the curve is 3. And then it says from 2 to 5, the area under the curve is 7. So if I want the whole thing, the area from 1 to 5 would be 3 plus 7, which is 10. So this is going to be 10 minus. Now, what's the integral from 1 to 5? Well, that's where I look at this guy right here, because now I'm dealing with a g of x. So I want to look at the function that has a g of x in it. But the problem is these are switched. Do you notice that? Okay, so how do you flip those around? Well, if I want to flip them around, I can totally do that. But do you remember what happens? Your answer just becomes negative. So that would be -4. So the integral from 1 to 5 of g of x is -4. But 10 minus -4 is the same as 10 plus 4, which is 14. Okay? All right, I'm actually going to stop the video and make a video for the second page so it loads faster, okay? See you in 1 second.